The root is discarded here. Let's review next. Whole router forwards packets. When the data is forwarded as a whole, each router. Actually, the parameters in the second layer are to be modified. Then why do you want to modify? When we learn the routing table of the complete body, everyone should understand. Because every time RA performs routing table lookup, local will see what is the outgoing interface on the device now. Now after this route is forwarded, this data is sent to the next device. For example, now the data arrives at the device. Then, before arriving, when sent from the previous device, the next hop address is the address of the left interface of the router. The device forwards this data, sent to RB. So now the destination IP address. It is the address of the left interface of RB. When we do data encapsulation, if the third layer is the address of this interface, and both of them are a directly connected network segment, from RA to RB, when it is making an ARP request, to request the MAC address of RB. That is, when this data is sent, the destination MAC is the MAC of this interface. The next time you retweet, destination MAC is its MAC. Further down the target MAC is its MAC. This is the purpose MAC. Let's look at the source MAC. When future data is forwarded as a whole, the source MAC will be the MAC of the outgoing interface. For the current data, each forwarding through a layer 3 router, separated by the interface of the router. On each different link, both the source MAC and the destination MAC will be changed. The router must know the next hop outgoing interface to send the data. Therefore, when the router forwards data, it will have some corresponding problems. The source MAC and destination MAC will be repackaged. This parameter will be changed. We will use the MAC of the outgoing interface as the source MAC, and the address of the next hop is used as the destination MAC. This is a concept between them. That is, data arrives at the router. Disassemble the second layer. Then look at the destination IP of the third layer. And then proceed to retweet. Forwarding process. The source port and destination port of layer 4 are unchanged. The source IP and destination IP of the third layer are unchanged. The source MAC and destination MAC of the second layer are always changing. Okay. Next, we will start to officially enter the part of static routing. What we just said are some basic concepts of routing. Static routing refers to manual configuration and maintenance by administrators. For example, now there is a routing device in the company. All routing entries inside, in addition to direct connection, I typed them one by one. For an enterprise network. In fact, only static routing is enough for small enterprise network. Also used by large enterprise networks. But it is not used as the main, because it will be more troublesome. As for the reason, we are in the process of experimenting. Can come to discuss. Let's first look at. This is the current terminal. Usually, the gateway is generally configured on a layer 3 switch. If I now send traffic to the gateway to export equipment, then export the equipment to the operator. This is a process of flow. We are often in the early stages of learning. The easiest thing to overlook. Traffic now goes to the gateway. No problem. Direct connection between gateway and egress device. No problem. In the future, we will write a static route pointing to the operator. No problem. The data can be exported as a whole. But what we tend to overlook the most is the how did this data come back? The operator now needs to reply data packet to these devices on the intranet. For example, Now the left is a network segment of 1.0. On the right is a 2.0 network segment. Then when the final data comes back, corresponding to return to 1.0 and 2.0. Otherwise the data will not come back. This is when using static routing. A more tedious part. You have to specify. This drawing is relatively simple. Let's discuss a slightly more complicated scenario. I draw it casually. Normal drawing is not like this. Real networking. It's not going to be grouped like this. Let's say this is some router. Simply make a connection. We are not discussing structural issues today. Assuming the current topology. That's how it's connected. For example, this device now has a network segment. More than one segment. There may be very many subnets. 1.0, 2.0, 3.0 etc. And I also want to subnet it. ABC that is not the main class is used. We also have a lot of subnetting. Then there could be hundreds of subnets. There are so many network segments on the left side of this router. The rightmost router is assumed to be 6. This is 1. For example, a PC is connected here. To access the following network segments. If you want to access the network segment of 1.0, then we have to write the root in the middle. The characteristics of static routing are to write one by one. For example, if you want to go to the 1.0 network segment from here, then write a. Not only this device needs to write. The equipment that passes along the way should also be written. For example, the current route is like this. Then the two devices. There must also be hundreds of subnets behind. Then each has to be configured individually. Some students may ask, can it be glued after it is configured? Can't. Because the next hop is different. On this device. For example, the next hop is the interface address. On this device say, the next hop is this interface. On this device is this interface. So there is also no possibility of bulk copying. Of course we can modify the next hop in the TXT document. Can but don't have to. Go to 1.0 like this. Go to 2.0 like this. Go to 3.0 like this. This is what we say. You need to configure manually. This is a characteristic of static routing. Then you have to write hundreds of articles. All the devices in the middle have to write these hundreds of entries. So compared to, it is more cumbersome. And now it's just traffic. Finally the data has to be returned. This device only knows how to go to 1.0 now. But it doesn't know how to get to the PC. So in the end this traffic have to keep pointing back. All the equipment along the way. Two-way routing must have. Otherwise, the traffic will not pass. Let's take ping as an example. Data goes back and forth. Then when the data comes back, there must be a route. So the limitation of static routing is that if there are more devices in the future, when there are many network segments, it's a little hard. It doesn't fit well. Because every node has to write. Overwork load. And more error prone. Not easy to troubleshoot. Because it is written statically. If you look at it,